All right, everybody. You ready to do this thing? Let's see. He's on his way. Gotta have our vacation music, right? Are you all ready for a break? What do you guys get to do over break? Anything exciting other than sleep? Do you get to leave the house? Nothing planned. Sometimes that's the best vacation is nothing, right? Nothing. Catch up on work is always good. I always think I'm going to do that, and then it never happens, right? So hopefully, we'll see. Hoping tomorrow I can get motivated to get you guys' stage work done, because I have my prep day tomorrow. So. All right. Let me share here and we get going. All right, everybody. Go ahead and get the essential question written down, the I can statement written down, and we will start here. Okay? We're gonna make an attempt. I might take Andy to downtown Disney. So we'll see. I don't know what we would do there, because all it is shopping, so that's just spending money. So but it's been almost a year to the day. I think next week's a year to the day that we've been to Disneyland. So. Hello, Nate. How you doing? What do you get to do over break, Nate? Do you get to leave the house, or is it more housework because you got the new house? Has anybody heard from your schools yet? Has anybody gotten in anywhere yet? So I know some of the Cal States are getting acceptances. I've gotten a few text messages about some news from my other students past few days. Well, that's good. Well, Madison, congratulations on getting accepted to the Cal States. That's good. That's good. What's your first choice, Madison? Not on the Cal States, just overall, what's your first choice? UCSD. I know a lot of people are waiting for UCSD. They're allowing kids on campus this year. Our family friend, we get all the decisions next month. I'm glad you're excited. Preparing to walk, so 30 minutes. It is kind of a walk at UCSD. It depends on what college you get into and where you have to start. I know somebody who's in sixth college. I think that's the newer one. This year he's literally, not all of his classes are online, but he's living in the dorms. So, but he has an ocean view. So I think he basically walks out to the beach and that's it. So I'm not sure he has to actually walk to class. So. Yep. It's a walk. It's a walk. That's okay, because here's what you won't happen. You won't put on the freshman 15 if you have to walk everywhere. Do you guys know what the freshman 15 is? No. The freshman 15 is where you gain 15 pounds. You got the senior 15. That's the COVID-19. The COVID-19, Nate. That's what we're calling it this year. I know. I keep telling myself I'm going to, lose I need to get out of my stretchy pants and into like jeans, right? Hasn't happened yet. And then they said school wasn't going to go back in until whenever, August. So I figure I still have more time, right? And my biggest problem is I still haven't lost the weight from, like Mikey and Davey, the baby weight. All right. I am, just full disclosure, there's still a few kids in my other second period taking a test. So if I look like I'm pausing, that's what's going on. All right, have we all written it down? Are we ready to go? So hopefully you don't gain the freshman 15. UCSD sounds like a good place to not gain the freshman 15, right? Because you have to walk a lot of places. And there's a lot of hills there, right? So you get nice and toned muscles. The school I went to, I only had to walk a quarter mile across campus. That was the furthest walk. And one of my classes was actually in my dorm because it was a super small school. But that was nice then it snowed. So when it was snowy, we actually had tunnels underneath the school. So tunnels underneath the school meant that you didn't have to walk out in the snow, at least for part of it. Then you got to a point where you had to go outside. Unfortunately, to eat, we had to go outside because the dining hall was not connected to the tunnels. So it was kind of cool. There weren't any boys allowed in the tunnels. And then some of them were kind of creepy. Like I didn't live in the dorm, like the dorm further beyond mine. I never went down those tunnels because those ones were super creepy. And the nuns lived there. There was a convent down there. So the nuns lived in that dorm, some of the dorm. So you'd sometimes see a nun in the tunnel. But yeah, they were older. It was like that building was probably, the one where the nuns lived was well over 100 years old. So and the tunnels were that old too. So it was really kind of I didn't like going down that part of the tunnels, but the rest of them weren't too bad. There were claims that, the hall I'm talking about was called Holy Spirit, and there were claims that it was haunted. So I never wanted to live there. I lived in the same dorm 3 years. It was a really tiny room, like an 8x10 box, because it actually used to be where they housed the nuns, because it used to be mostly nuns that went to school there. But then my senior year, I got to move to a bigger dorm where it was a single. I highly recommend having a roommate. So if you have the opportunity to have a roommate, have a roommate. I never had a roommate, and it was probably the biggest mistake I made in college because I didn't meet very many people. I was kind of a by myself kind of person for 4 years. So I had a few friends, not many. And most of them I met because I was in classes with them. So if you can, live on campus and have a roommate. That's my advice. All right, are we ready? Let's do this thing. Geez, I missed half the chat there somehow my thing didn't scroll. I didn't watch anything like that. Don't worry about your roommate being a psychopath. Most of the time, like 90% of the time, it works out. Because I do think they have you like fill out nerd surveys and stuff. So that you'll hopefully get someone decent. But I highly recommend a roommate. All right, here we go. Let's talk about absolute and conditional convergence. I decided to only do one lesson. The plan is to do our test on this. We have one more thing after this, but it's super short. So we'll do that the Monday we get back, plus I'll have the test review ready to go. If I get really motivated tomorrow, I might be able to put the test review out for you then. So you're ready to come in and ask questions. I might, if I get that done, then I might have you do the last lesson on video, and then you come in and ask questions on whatever you want for the Monday lesson, since the Wednesday lesson is shorter. And you guys might get a bonus if you guys want to come in and we can do the Friday test with the other class again if you want, if you like that. And then kind of Thursday would be optional. You can either come in and ask questions or you can have it to study. So that's kind of where my brain is going right now because I want to get this test over and done with before the triad grades. Okay. When does the triad end? Can you guys tell me that in the chat? Do you guys know? Yeah, the 26th. So we're done on a week, 2 weeks from tomorrow. Okay, but it's kind of deceiving because we have a week off, which I know we all say we're going to do stuff. I do too, and everything never gets done, right? So unless we're super motivated. So, all right, let's talk absolute conditional. So a concept of absolute and conditional convergence are used to determine the convergence or divergence of a series in which the terms are sometimes positive and sometimes negative, but not necessarily alternating. Okay, so that's when we end up using this. Sometimes they alternate, sometimes they don't. So we begin this analysis of series behavior with the following theorem. So if the absolute value of a series converges, then the series without the absolute value will also converge, okay? The converse of the theorem is not true. For instance, the alternating harmonic series, it converges by the alternating series test, yet the harmonic series diverges. This is what type of convergence we call conditional, meaning it diverges by one test, but it converges by another, so we call that conditionally convergent when that happens, okay? So the official theorem is that if the absolute, we know the original is convergent if the absolute value converges, and we call that absolutely convergent, okay? If the original is convergent, but the absolute value diverges, then we call that conditionally convergent, okay? So let's try a couple of these, okay? So this one here, what tests do you guys think we should use on this? You guys have your orange sheets out ready to go? What tests do you think we should use on this? I don't think I have my orange sheet up. Let me find my orange sheet. I'll go pull it out of Google Classroom. That's where I know it's at. I did post the latest and greatest version of it with everything on it. All right, so there it is. And I'm seeing a lot of ratio, and it's probably because of the exclamation point, right? So sorry, I said that totally wrong. It's because of the factorial. It's not called an exclamation point. Sorry, they're asking questions. Going way too slow. Okay. Let's try the ratio test on it, okay, and see what happens, because the ratio test actually has a piece of it where it says it's absolutely convergent if this happens, right? Oh, you can't see that. It's absolutely convergent if we know this happens. So typically we would go to ratio or root if we can, but we don't have to necessarily use those ones to do absolute and conditional convergence, okay? So let's get it plugged in. What am I going to plug in anytime I see n for ratio test? Go find yourself some lunch. Not you guys, Andy. All right, n plus 1, nice. Okay, and we can drop the -1 because it's absolute value, right? So I'm going to find the limit as n approaches infinity of n plus 1 factorial over 2 to the n plus 1 times 2 to the n over n factorial, okay? And then we're going to expand this, the limit as n approaches infinity of n plus 1 times n factorial over 2 to the n times 2 to the first times 2 to the n over n factorial. Hang on a second. I'm going to mute because I got to yell at him because he's not doing what he's supposed to. I can hear it from here. All right. Hopefully he'll now get himself some lunch. If you're not going to do what mom says, don't go play with something noisy, right? Because mom can hear you. All right. Isn't that the truth, right? Okay. So we're going to do some canceling. We're going to get rid of the n factorials and get rid of the 2 to the n. So we have the limit as n approaches infinity of n plus 1 over 2. That 2 is to the first power. That is correct, Josue. Okay, that one in the denominator. And this one here that I just did, that's the first power. All right. So when we take this limit, when we put infinity in, don't we end up getting infinity? Because it's infinity over 2. Well, I'm going to go back and check my orange sheet and see what happened. It looks like this one, it diverges, right? This says diverges if it equals infinity. Okay? So let's take so we're going to say, therefore, diverges by, and again, it's not a bad idea to tell us what test, ratio test. Give you a second to write that down. Okay. Is it absolutely only for converge or for both? I'm going to go look at the orange chart again. Let's read it. Okay. So it will absolutely converge if I get if this is true, if its absolute value is less than 1. It officially diverges if we have it equal to infinity or it's greater than 1. It will conditionally converge if we can get it to do something else. With ratio tests, we don't usually have a whole lot of conditional convergence. We go to the inconclusive part. Okay. So we're not going to do on ratio. If we're going to use ratio tests, we don't need to use another test. Okay. But let's look at the second one. When you see the second one, you'll see a little bit of a difference. Okay. Hopefully. All right. So because this one, the only other test I would have possibly done on it would be nth term, maybe, right? I wouldn't have picked something else. And if I used nth term on it, it was going to diverge as well. So no matter what I was going to do, I was going to get a divergence on that one. Okay. It's just the nature of the beast of that one. All right, so let's look at B and see what we can figure out about B. So the first thing, if I was just looking at that one the way it is without absolute values on it, what test would we use on it? What do you guys think? Go back and look at your tests. We've got -1 to the n over the square root of n. So what test do you think we would use? Okay, Nate's suggesting alternating. What does everybody else think? Hello, Anna. Welcome to class.
Hi, Miss Ballard.
All right, Madison thinks alternating. All right, we've got that -1, and that's our red flag for alternating. And that's something we're going to do when we get back. We will probably do an activity either Monday or Wednesday. Probably better do it on Monday, huh? That we talk about how to tell the difference a little bit more. Okay, so again, we have looked at like the flow chart, use that. You get to use it on my test, not on the AP test, but on my test, you'll get to use it. So we definitely look like we're alternating there. So let's start with the alternating series test. So the first part of the alternating series test is knowing that the limit as n approaches infinity of 1, and remember, we ignore the negative on this piece. We have to decide what that equals. So when I put in the infinity, what do I end up with that equaling? You guys tell me in the chat, what does that equal? Yep, 0, good. So that's step 1, we proved that part. Now I just have to prove to myself that the terms are decreasing. So I assigned a Delta Math assignment. So do the best. A lot of it is similar to this, okay? You're going to have to do some explaining. They're going to explaining is different, so it might not be a bad idea to watch their video too, because getting somebody else's take on this is not the worst thing in the world, okay? And hopefully you'll be, and if you have struggle getting through it, let me know. I'll help you, okay? I tried it. I've been a little nervous about some of their newer BC assignments, but we're going to try it this time. Okay, so I'm plugging in 1. So 1 over 1 square root of 1 would be 1. 1 over square root of 2 1 over square root of 3, 1 over square root of 4 would be 1/2, and so on. And so it looks like we're decreasing. Okay, so it looks like I'm very confident that we're going to decrease. So we definitely know that it converges by the alternating series test. So therefore, converges by alternating series test. But what we're supposed to be looking for, is it absolutely convergent or is it conditionally convergent? Okay, so what I have to do now is run another test with the absolute value of the series. So if I rewrote that series with the absolute value of it, n equals 1 to infinity, the absolute value would take away the -1. So it'd be 1 over the square root of, let me rewrite that again, I'm sorry. Be -1 to the n over the square root of n. When I take the absolute value of it, that turns it into 1 over the square root of n, which is the same as saying 1 over n to the 1/2 power. So now I have to see if that series, that's the absolute value of the original, to see if that one converges or diverges. So what type of series test am I going to run on that one? Yeah, that's like the favorite, right? The P series. So this is a P series. Okay, with P equal to 1/2, which is between 0 and 1. So if P is between 0 and 1, again, your orange sheet, that's your like new best friend, right? Get that baby in front of you. If P is between 0 and 1, does it converge or diverge? Oh, Nate, you were like 3 steps ahead today. So this one diverges, right? So therefore, overall, right, we are conditionally convergent. But I know it just clicked, right? Because you were able to get me. Oh, you got the gist. Good job. So the delta math wasn't too bad. That's good though. No, it stinks. I'm sorry. All right, it's only 5 problems. You can do it. All right. So if you got the gist of it though, it was good. Remember that you only have a few months of Mrs. Ballard left, right? You have to go learn your lessons next year completely on your own, right? Because you're going to have a college professor that possibly might not. You don't want to. You're yay that you get to you're leaving. Yeah. So I agree. It's kind of it's a double-edged sword, right? It's good to go because you guys are ready, but it's kind of sad too. Hopefully you don't get the guy that writes with one hand and erases with the other at the same time. There are a few of them still out there. So I still about 5 years ago had a report out of UCR that there was still a guy that did that. So because they still have a few, I know they've got whiteboards at UCR because we've done a few of those, but I don't know why they would do that because it's efficient, because then they don't have to, when they're done, you have to waste time erasing the board. I'm serious. There's professors that do that. So you have to write super fast too. So it's a little different for you guys. Most of them have come into the technology age, but not all of them. Not all of them yet. All right, let's see what I did with this one here. I don't think I have this one in my, what did I do? Okay, let's see how we do with this one. Where are we at on time? 12:10. We got 20 minutes. I think I didn't pull up all of my notes that I needed to pull up here. All right, so looking at that one there, let's see if we can figure out absolute or conditional on that one. That test is a little bit tougher to determine which one to use though, right? So let's see. I can't put 0 in there, right? Because it would be, I could put 0 in. Oh, it looks like maybe alternating. I don't know. Let's see what we got. Let me look at trying to pull my cheat sheet from last year or 2 years ago, because I don't think I did this last year. We didn't get, maybe we did get this far. We got to this, and this was kind of it. Let's see, do I have that one somewhere? There it is. Okay. So the first thing I want to do is I want to see if I can just pick a test for it to, looking at the chat. All right, so I see the -1 and I would say alternating, right? Everybody would agree with me alternating? Okay, so let's try it by alternating. So the first thing we're gonna look at is the limit as n approaches infinity of n over n plus 5. What does that end up equaling? You guys tell me, what does that end up equaling? Yeah, that's going to be 1, which means that alternating is inconclusive, right? Oh, alternating series test, AST. AST is inconclusive. So, but we technically just did nth term, right? Because that is the nth term test. And by the nth term test, let's look that up on our orange sheet. Where's my orange sheet? Nth term, if it doesn't equal 0, it automatically diverges. So as soon as I get it diverging, and technically that would be diverging with the absolute values on it, right? I know that it just diverges. It's not conditionally convergent or anything. So therefore, diverges by nth term test. Okay. All right, let's take a look at the next chunk here. Okay, so there's a couple of flowcharts here to kind of help you. I don't know if I can, there we go, zoom in. They're a little fuzzy to zoom in on. Hopefully they look a little bit better on your papers. So this one here is basically, hey, you got to figure out if the original series converges or diverges, right? And then if it converges, you have to decide is it absolutely convergent or conditionally convergent. So that's where you put the absolute value on it and decide if it converges or diverges. Okay. And then the test the series of absolute value. So if the absolute value converges here, then it's absolutely convergent. If it diverges, that's where we get it's conditionally convergent or divergent. That's why they typically do this one first, because it's conclusive and I don't have to do another test. It really doesn't matter what order if you do the absolute value one or the other one first. But all right, let's look at example 2 here. All right, so I am going, this one's a lot uglier, isn't it? So it looks like I could do an alternating. Looking at what they did with it. They didn't do an alternating. They did a comparison series. I wonder if we could just do a ratio test on it. But I know that the homework was doing like a P series thing, wasn't it? Let's try ratio test on it and see if we can get ratio test to work. How's that sound? Okay. So we're going to do ratio because we know really well if it converges or diverges, and we go right into the absolute value, right, with ratio. So ratio test, we have to do, what do we have to plug in for ratio test? It was nth or alternating the limit comparison or P series. Yeah, that's what the homework was saying. This one here, because I'm looking at the answer key by someone who is smarter than me, they compared it to a P series, but I don't know that we need to necessarily do that. I'm looking at the next one too a little bit. Okay, all right, let's see how we do. So let's see what happens with ratio. Let's plug in our n+1. So we have the limit as n approaches infinity of the square root of n+1 over n plus 1 squared plus 1. And technically the absolute value of that, oh, we've got to multiply by the reciprocal. This might have been a mistake. So let's see. N squared plus 1 over the square. Actually, we did this one the other day, I think, by ratio. Okay, so on this one here, wouldn't our exponents, even though I can't really cancel anything out, right? If I think about my exponents, the exponent on this one here is n to the 1/2 power. The exponent on this is squared. The exponent on that is squared. The exponent on that is 1/2. So don't I have the same exponents? So my limit is just going to be the coefficients in front. So what's my limit equal to on this one? All right, it is equal to 1. Nice job, you guys. So let's go back to our test. So if I am exactly, oh, I know why we can't do ratio. Look at what happened. We got that it was inconclusive. So much for ratio test. Let's try something else. All right. So inconclusive, even though we tried ratio. I'm not spelling it right. Inconclusive. Which is okay. We can hit a dead end. That's all right. Sometimes that happens. All right. So let's take a look at doing the absolute value of this and trying to find the comparison. Because if I can get the absolute value to go, because I don't know what to do with it, alternating I don't think would be any better. Trying to put that in. Because look at what happened with what we had. We would be getting a limit of 1 almost if I did the alternating series test. Because if I tried to do the limit of this piece, maybe not. So, but let's try. So let's try just finding the absolute value of it. So n equals 1 to infinity. The absolute value of -1 to the n plus 1 square root of n over n squared plus 1. So what that means is I'm really looking at the sum as n equals 1 to infinity of the square root of n over n squared plus 1. All right, so obviously we're going to have to do a comparison test of some kind, right? So I'm going to try to figure out what to compare to. So I'm seeing my numerator looks like n to the 1/2. My denominator is an n squared. So if I went ahead and I subtracted those, I would get n to the, this is 4/2, right? -3/2, or 1 over n to the 3/2. That's what I'm going to use, which we kind of like, because what kind of a series did we just create? What kind of a series is that? Yeah, that's our good old P series, and P is equal to 3/2, which is greater than 1. So does that mean the P series converges or diverges? Yeah, it converges. Good. Okay. So what that means, because I got the absolute value to converge, that means that the original should converge. So as long as the absolute value converges, it converges absolutely. Okay. So the other thing I have to do is I have to make sure that, because I just did a BCSD, right? BCSD. That's the comparison test that I'm running here. I could have probably done limit, but I ended up with BCSD. So I need to know that the original series was smaller, right? So I've got 1 over n to the 3/2. I'm comparing that to the square root of n over n squared plus 1. I just need to double check my terms here and see what make sure I'm I'm one of, they're smaller, right? So this, if I put in 1, I'd be 1 over 2, and this would be 1 over 1. Okay, let's try another term. Square root of 2 over 4 plus 1, 5. And this would be 1 over 2 square root of 2 cubed. We'd probably need to go calculator, right? Find the decimal point. So I'm pulling out my handy dandy iPhone, right? So just so I can double check to make it sure it's smaller, square root of 2 divided by 5. That's what I got. And then 1 divided by square root of 8 is what that would be, right? Is 0.35. So I'm pretty confident that the comparison series was bigger, okay? So since I got that, I know that it converges absolutely. So therefore converges absolutely. All right, let's see what sorry, one of my teachers just called. Okay. Normally my teachers that are in my department, they changed to K. Oh, in the next one, yes, they changed to K. It's not a big deal. You'll see Ks, you'll see Ns. All right, so either way, we're gonna go with it. All right, so let's see. We could do this one of two ways, it looks like, okay? Do you guys wanna run, either we run nth term or we run ratio? What do you guys wanna do? Nth term or ratio? Which one do we like better? Nth term first? Okay, Nate wants to do nth term. Okay, so we're going to try the nth term test. So again, we're going to look at the limit as n approaches infinity of -1 k plus 1 2 to the k over k squared. All right, technically, which one gets bigger first? I'm not worried about the alternating piece at the top, okay? Is the exponential on the top going to grow faster than the squared on the bottom? Or is the bottom going to grow faster than the top? So which one's going to grow faster, the numerator or the denominator? What do you guys think? Think about this. So this is the parabola, right? And then the exponential tends to go like this. So who's going to win? The exponential on the numerator or the squared in the denominator? Okay, our brain hurts. Let's try it this way. Let's try a t-chart for both of them, right? So x and 2 to the k and x squared, right? So if I put in a 1, I get 2. If I put in a 1, I get 1. If I put in a 2, we get 4. If I put in a 2, they're tied, right? What happens when we go to the next one? 3. 2 cubed is 8. 2 squared, ooh, is 9. What happens if I keep going? Because the exponential is supposed to win when I go to infinity. Let's put in something really big. Let's put in 10. 2 to the 10th. 10 squared is 100. What's 2 to the 10th? I don't know. Let's see what the handy dandy iPhone calculator does. 2 to the 10th. Oh, look at 2 to the 10th. 10 to, oh, Nate got it before I did. 1024. So who wins? Does the exponential win or does the parabola or does the squared win? All right, it's the exponential. So the exponential, you guys, is always going to dominate over a polynomial, okay, especially a squared, okay? I saw that word in the notes that I've kind of been using. I like that word dominates, right? So the exponential is going to dominate. So that means this is getting bigger than this. That means it's going to go to infinity. All right, which means on nth term test, what does that say? Nth term test, it doesn't equal 0. So what does that mean that's going to happen with the nth term test? Is it converge or diverge? Yeah, it diverges. So therefore, diverges by nth term. Okay. You guys, I know this wasn't easy today. You guys did a really good job. Okay. try the Delta Math, use their videos, see if you can gain some more insight into this one, okay? And then if we need to revisit, let me know, okay? Other than that, I hope you all have it. Oh, we need a joke, don't we? We've earned our joke today, haven't we? Because it's the end of the lesson, and let's see what Andy has for us today. He's been here all week because he lives here, so let's see what he's got. He's on the new sofa. We got the new sofa. Finally.
Hello. I was the video gamer alone on Valentine's Day.
So why was the video gamer alone on Valentine's Day? This is a good one.
He was spending too much time with his Xbox. Very sad. I'll be here all week because I live here.
So gentlemen, if you don't want to be alone on Valentine's Day, don't spend too much time on your Xbox. And of course the tagline. Oh, I know what I didn't show you guys. Oh, the t-shirt. Zeta made a t-shirt. You guys want to see the t-shirt? Let me get the t-shirt. Okay. And the other class is right now thinking like dark green with maybe yellow writing. We only do one color because I'm cheap. So, all right, let me find it. Let's see, I need Google Classroom because that's where it's hiding. So give me a minute to get there. Bear with me and you can see the t-shirt. Uh-oh, what happened? Oh, there you guys are. Thought you disappeared for a second. And who knows if he actually ate lunch, right? Okay, let's go to fourth period. So she's got a front and a back. I think we should put names on the back, but separate the names, and you'll see why here in a second. Okay, so the front, two attachments. Fourth period nominated Zeta to make the shirt. So this is like the first time since our very first shirt that I haven't been the one making the shirt. So there's the front. And she's got our little series notation in there for whatchamacallit, for BC. And then the back looks like that. And then I think we should maybe put our names underneath the back, but like separate it out really big. Like big space between the names. What do you guys think? You like it? That's good. What do you guys think about dark green? Do you like dark green with either yellow or white font? Anna says we should put the back on the front. It took you a whole minute to get it. I was impressed that we came up with the distance formula, though. I thought that was pretty good. Because it's not really a calculus thing. The hard part is I don't think we can put the front on the back. Like, I think that has to be the front. And it took me like 2 or 3 times of looking at this to figure out that it was the computer screen and us all looking at the computer screen. So I will definitely forever remember this class. Casey likes white font. Are we good with dark green shirts? Yeah, we like the dark green. It's been funny the last 2 years, everybody's wanted green because they don't think we got our fill of it because we haven't been on campus. So previous years, nobody wanted green. And I ban red. I won't let you have red. Sorry. No red for us. It got darker when you washed it? Yeah, okay. Last year's, mine hasn't gotten darker at all because last year's was the Kelly green. So I've been wanting a Kelly green one. Oh, another shirt messed it up. Which I've been wanting a Kelly green one for years and years. Then everybody keeps picking the teal blue. So, all right, you guys. I won't see you tomorrow. So unless you guys want to come play Kahoot, I'm doing Kahoot tomorrow afternoon. I have no clue what kind of green that is. Is that what the green was from last year? Is that the green we want for this year? It sounds fancy, doesn't it? Oh, for this year? All right, I'll see what I can do. I'm not sure. Because I always buy the Gildan like soft style shirts. So it has to be that shirt. Okay. Oh, you're pulling out the paint swaps. All right. So I won't see you tomorrow. So the next time I see you is after break. All right. So I hope you all have a great break. Okay. Go get yourself some lunch because I know you all have a 5th period class to go to. Okay. Oh, not 5th period. What's today? 3rd period class to go to. I'm totally off. All right. So have a great day. I will see you after break. Okay. Make sure your work's turned in and caught up. Bye, you too, Madison. Bye, Josue, you too. Bye, Nate, you too. Bye, Casey. Bye, Anna. You two have a good break.